Hey, this is Presh Talwalkar. A miser can make one cigarette from 5 cigarette butts. What is the most number of cigarettes the miser can make from 1,000 cigarette butts? While you're working on this problem, I'm going to pose another problem. The number 100 has 2 trailing zeros. The number ends in 2 zeros. The number 30,020 has 1 trailing zero because it ends in 1 zero. The number 1034 has no trailing zeros. It does not end in a zero. How many trailing zeros are there in the number 1000 factorial? Give these problems a try, and when you're ready, keep watching the video for the solutions. We'll get started with the miser. Every 5 cigarette butts he can craft into a new cigarette. So we can divide the number of cigarette butts by 5 to get the number of cigarettes he can make. He starts out with 1,000 cigarette butts, so that means if you divide that by 5, he can craft 200 cigarettes. And some people think this is the answer. But if you think a little creatively, he can now smoke these 200 cigarettes to get 200 more cigarette butts. From those 200 cigarette butts, he can then craft another 40 cigarettes. Why stop there? He can smoke these 40 cigarettes to get 40 more cigarette butts. He can then craft another 8 cigarettes out of that. And if he smokes these 8 cigarettes, well, the number 5 goes into this one more time. We can get the total number of cigarettes the miser can make by adding these numbers up. We have 200 plus 40 plus 8 plus 1, which gets us the answer of 249 cigarettes. So what does this have to do with factorials and trailing zeros? The first observation is that the number of trailing zeros in a number corresponds to the number of times it has a factor of 10. 10 is equal to 2 times 5. If we can count the number of factors of 2 and the number of factors of 5s, then we'll have the number of factors of 10. Now notice that every other number is an even number which has a factor of 2, whereas only every fifth number has a factor of 5. So we're going to have a lot more factors of 2 than there are factors of 5. So when we're creating these factors of 10, the limiting reagent is the number of factors of 5. So we can count the number of factors of 10 by counting the number of factors of 5 in 1000 factorial. We can do that by counting the number of factors of 5 in the numbers 1 through 1000. So we take the maximum number and divide it by 5 to get the number of factors of 5 there are, because the factor of 5 happens every 5 terms. So from the numbers 1 to 1000, we divide by 5 to get that there are 200 factors of 5. Every fifth number contributes one factor of 5 to the power of 1. But why stop there? If we look at every 25th number, we get one more factor of 5. So we then get that there are 40 numbers which have a factor of 5 squared. We get 40 more factors of 5 out of this. We can then divide by 5 one more time. This will give us that there are 8 more terms which have factors of 5 to the cubed. This is 125. If we go one more time, we can only end up with one more term. This will have a factor of 625. To get the total number of factors, we count up these terms, 200 plus 40 plus 8 plus 1, and that gets us to the answer that there are 249 trailing zeros in 1000 factorial. And it's really cool that we can figure out the number of zeros in this really immensely big number without actually having to do the calculation of figuring out what the exact answer is. We can simply count the number of factors of 5. Did you figure out these problems? Thanks for watching this video. Please subscribe to my channel. I make videos on math and game theory. You can catch me on my blog, Mind Your Decisions, which you can follow on Facebook, Google+, and Patreon. You can catch me on social media at Presh Talwalkar. And if you like this video, please check out my books. There are links in the video description.